Welcome again. Today on Chem in 3, we look at definitions of Lewis acids and Lewis bases. We note that when a Lewis base reacts with a Lewis acid, a coordinate bond is formed. We also classify Lewis acids and bases as nucleophiles and electrophiles. And then finally, we make connections to all of this with organic and inorganic chemistry. A model of the ammonium molecule. Here you can see the central nitrogen atom covalently bonded to 3 hydrogens with its lone pair of electrons here. Ammonia is an example of a Bronsted-Lowry base because it can accept a proton. It can also be classified as a Lewis base because it possesses a lone pair which it can donate and form a coordinate covalent bond with a species that accepts this bond. The species that gives the lone pair is a Lewis base, and the one that accepts it would be classified as a Lewis acid. But a Lewis base could also be classified as a nucleophile. And the term nucleophile literally means in search of a positive center. And here you can see the OH negative ion behaving as a nucleophile in this nucleophilic substitution reaction as it searches for a positive center, using this lone pair to donate to this positive center. And in so doing, it's a nucleophile, but it can also behave as a Bronsted-Lowry base and accept a proton. And here, it's behaving as a Lewis base as it donates its lone pair. Is also an example of a monodentate ligand. And Lewis bases are capable of being monodentate ligands, which means that they can donate this lone pair and form coordinate bonds with the central metal ion in transition element complexes. A Lewis acid is a species that can accept a lone pair. BF3, boron trifluoride, is an example of a Lewis acid. But in the case of BF3, unlike NH3, ammonia, it is not a Bronsted-Lowry acid because it's not capable of donating a proton to fit the definition of a Bronsted-Lowry acid as a proton donor. But it is an electrophile, which literally means in search of a negative center. Here an example of an electrophile in organic chemistry is NO2 positive, which is attracted to the negative center of the benzene molecule, and as such it's classified as an electrophile. Now you might ask, how is BF3 an electrophile? Surely you can see it's a Lewis acid, but how is it an electrophile? And here you can see if we brought this Lewis base, NH3, to react with this Lewis acid, BF3, then this lone pair of electrons would be donated here, and this coordinate covalent bond would be established. A coordinate covalent bond being one where one species has donated both electrons for the covalent bond. And here you can see that NH3 has donated electrons and it has behaved as a Lewis base. It has also behaved as a nucleophile, whereas BF3 has behaved as a Lewis acid and it has also behaved as an electrophile. Now I'd like you to find another example of a Lewis acid and a Lewis base and to consider how they react with each other.